Welcome everyone to this short tutorial on how to deploy Apache Pulsar to a Kubernetes environment with Helm. My name is Axel Sirota, and I am a machine learning engineer, speaker, Apache Pulsar fan, and I am very excited to present this to you. We will revisit shortly how to deploy with the new Helm Charts both to Minikube as a local development environment as well as Google Kubernetes Engine as a production environment. To use the Apache Pulsar Helm Charts, we need a Kubernetes server with version after 1.14.0, kube control with version after 1.14.0, and Helm free. We will not cover how to install them, but I recommend checking out ASDF. ASDF is a tool that manages tool versions really well in a local as well as global scope. To deploy Apache Pulsar to Minikube, we will first prepare the Minikube cluster. It is a requirement for this section to have Minikube installed. We create a new Kubernetes cluster running Minikube start -- memory 8 GB -- CPU 4, where we are specifying we need to use the 4 CPUs and 8 GB of RAM. We can also specify the Kubernetes version if needed. This command takes a couple of minutes, so I will advance to the end, but if you are coding along, I recommend going for a cup of coffee. Now we have a running cluster. I recommend checking 2 seconds if our kube control version matches the one on Minikube to avoid API mismatches. This is simply running kube control version. In my case, we can verify my kube control version differs from the one on the Minikube server only by 2 patches, so we are okay. Also, it is advisable to check a moment if the server kube control is looking into is Minikube. To do that, we run kubecontrol get nodes. In our case, it is so excellent. If it wasn't, we only needed to run kubecontrol config use context Minikube. Okay, now our cluster is ready to get Pulsar. Let's prepare the release. For that purpose, the Helm Charts repo comes with a script called prepare Helm release that creates tokens for authentication, creates the keys for super users, creates the users for Grafana, Prometheus, and Pulsar Manager, and creates the namespace for Pulsar. We run it in the terminal like the following: git clone and the repo of the Pulsar Helm Chart repo. We cd into the directory of the repo, and we run scripts -pulsars -prepare helm release -n pulsar -k for the release pulsar -mini -c to create the namespace. Success! Now we can deploy easily to Minikube with Helm, with the examples value file in the same repo we cloned. Let's add the Apache -pulsar Helm Charts and install it. First, we do helm repo add Apache and the charts. Then we do a repo update. And finally, we run helm install pulsar mini Apache -pulsar with the values as --values examples \values -minikube.yaml, which is an examples value file that was provided in the repo. After a minute or two, we are done. Excellent! As you can tell, the Pulsar team made it fairly simple to deploy Pulsar, so we can experiment easily. Helm takes a bit to deploy, because we need several components. Take a time to relax and enjoy while Kubernetes does the rest. In case you prefer to keep an eye, I recommend setting a watch like the following: watch -n2 kubecontrol -n pulsar get all. Once all the pods are running or completed, we are ready. Okay, now Pulsar is up and running. To verify this, we will first look into the operational tasks we have at our disposal, and later we will do a simple publish-subscribe to end the local development section. If we run kubectl-n pulsar get services, we can verify we have free load balancers that can be accessed by outside the cluster. Minikube offers the subcommand service to access them easily through the browser. If we run minikube service-n pulsar, pulsar-mini-pulsar-manager, we will be redirected to Pulsar Manager. Pulsar Manager is a web-based GUI management tool for managing and monitoring Pulsar. The username and password are pulsar-pulsar. We will create a new environment setting the name we prefer and setting the broker web port as the one inside the Minikube cluster. That means http://pulsar-mini-broker at port 8080. Once we click on Confirm, we have a UI for managing Pulsar. Let's create a tenant Apache on the cluster Pulsar-mini. Now, clicking on Apache, let's create a namespace Pulsar. Remember that namespaces are logical separations of topics within a tenant. Finally, we can create a topic within the Pulsar Manager by clicking on the Pulsar namespace, then on the Topics tab, and finally on the New Topic. It will be persistent with the name Demo and 4 partitions. Pulsar Manager is an excellent initiative to manage Pulsar intuitively. Let's test our newly created topic by sending and retrieving messages from it. To do such, we need Apache Pulsar 260 and at least Java 11 on our laptops. I have it already installed to avoid making this video longer, but you can check the instructions to do so here. https://github.com Axel Sirota handling streaming Apache Pulsar. Let's test our newly created topic by sending and retrieving messages from it. To do such, we need Apache Pulsar 260 and at least Java 11 on our laptops. I have it already installed to avoid making this video longer, but you can check the instructions to do so here. https://github.com Axel Sirota handling streaming Apache Pulsar. Now we need the URI of the broker binary and web port to set them in our client config. The best way of fetching those is running minikube service pulsar-mini-proxy --url-n pulsar. The first of those URIs is the web port, and the second the binary port. I will open a new tab and go to my Apache Pulsar installation. I will open the client config under conf/client.conf. Now on web service URL I will put the URL copied, and on the broker service URL I will set the second URL. Okay, awesome! We will save and we are done. Let's open a subscription to our new topic. We do this by running bin/pulsar client consume on the subscription sub on the topic apache/pulsar/demo and wait for infinity, that is -n0. We can verify Now we have an open subscription, and now we can go to another tab and produce some messages. On another tab, we run bin/Pulsar client produce on the topic Apache Pulsar demo. The message is hello Apache Pulsar, and we will send 10 messages. If we go to the previous tab, we can verify it worked. Excellent! Now we have a fully functional Pulsar deployment on Minikube. Another useful service offered by the Helm Charts is monitoring by Prometheus and Grafana. As its impact is higher in production usages, we will revisit it with Google Kubernetes Engine deployment. However, bear in mind the process of accessing it in Minikube is the same as with the Pulsar Manager. We covered a lot in this section, so better to leave with some takeaways and a checklist for your Pulsar in Minikube experience. Remember that we can prepare the Minikube cluster with the prepare Helm release script. From there, we just deploy using Helm and the examples /values-minikube values file. Using Minikube service, one can create a tunnel into the Pulsar Manager and Grafana. And getting the URL of the broker is also simple using Minikube service --URL. And using that, we can use the Pulsar client CLI as usual. Now, let's revisit how to deploy the Helm Charts to Google Kubernetes Engine as a production environment. To deploy Apache Pulsar to Google Kubernetes Engine, we first need a project in the Google Cloud Platform. In case you are unfamiliar with GCP, we just go to https://console.cloud.google.com and create an account with our Google Mail and set a payment. There, we can create our first project, which is a way of splitting entities in GCP. Once we have that, we can go to GKE and enable the creation of clusters. That operation takes a couple of minutes in case you haven't done it beforehand. Finally, we need to install the gcloud SDK and set it up correctly. Next, on our terminal, the best way of creating our new cluster is by using the script provided by StreamNative. So, we clone the StreamNative charts, we cd into the StreamNative charts, and then we run the script gke bootstrap script app, where I pass the environment variable project as pulsar-gke-deployment. I set the project variable as that because that is the project I created on my own GCP account, but put your own. The Bootstrap script will create service accounts with the corresponding roles, create a cluster with 4 nodes in GKE, create the local config directory for authentication, and configure kubectl to point to the new cluster. It takes a while, so feel free to pause the video and take a walk or stretch. We are back. And if we run kubectl version, we verify now it is advisable for me to have kubectl version 1.16. We can easily do that in ASDF. We just run ASDF local kubectl 1.16.13 and that's it. We can verify again that the Pulsar team went above and beyond their effort of making it extra simple to experiment and deploy Pulsar in production environments. One script and we have a full cluster. Now, to prepare the Helm deployment, we run again the prepare Helm release script from the Pulsar Helm Charts repository. Notice that this time the release will be named Pulsar-GKE. After this runs, we can deploy Pulsar. To have a basic deployment with persistence, on manual storages that GKE will auto-create for us, we only need to run helm install pulsar --set initialize as true --set volumes.persistence as true Apache/pulsar-n pulsar. Let's revisit what this is doing. It is deploying the pulsar charts with the default values. It is overriding the value for initializing and set to true. This should only be done the first time we run the install. It is setting the persistence as true and create the persistent volume claims such that GKE will generate persistent volumes. I personally do not recommend to deploy local storages to GKE unless you have one already running and you know what you are doing, because it is easy to mix things up. And as easy as that, in 4 or 5 minutes, Pulsar will be up and running. Let's wait. Okay, that was a lot of waiting. Before revisiting where to learn how to add features to this deployment, such as TLS encryption, authentication and authorization, and tiered storage, let's do the same test again of creating topics via the Pulsar Manager, sending messages, and checking the monitoring on Grafana this time. If we go to the GKE tab Services, we click on the Pulsar Manager URL, we get redirected to the same Pulsar Manager. Check that this time we didn't need to create a tunnel. Now we have to do the same process as before. We log in as Pulsar. We create a new environment and select the broker URL as http://pulsar-gke-broker at port 8080. We create a new tenant Apache to the cluster Pulsar-GKE. We create a new namespace Pulsar. And now we will create a new persistent topic demo with 4 partitions. With that, we have a topic already running. Let's hit that. We can copy the IP of the broker instance and copy it in our conf client.conf config. We will change the web service URL as the IP we got, and we keep the port as 8080 because TLS is not on, and we will change the broker service URL as the IP we got and the port 6650 because TLS is not on. Bear in mind that if it was, we would need to change Pulsar at the start of our URL for Pulsar plus SSL. When we save, we are done. If this sounds similar to you, it is because it is the same process. We are pointing our Pulsar client to the new cluster. Now we will create a subscription, running pulsar-client consume with a subscription sub on the topic demo and wait for all messages. And it worked. Now we go to another tab and let's send some messages. Pulsar-client produce on the topic demo, and we will send the message hello Apache Pulsar 10 times. We can check that it actually sent the messages, and we go back to our tab and we see we got the messages. However, this time the messages went through the Apache Pulsar deployed in GKE as a production environment. Cool. To end, we can go back to Services in GKE and click on Grafana. This will redirect us to the login page where we log in as Pulsar. We can check all the metrics Prometheus is publishing constantly about our Pulsar deployment. with persistence, and all this will come for free in the charts. We can go to the Bookies dashboard and check their throughput and availability, which is extremely important in Pulsar. In case you are wondering how to add extra features to this deployment, it is actually super simple. You just need to change the values accordingly as we did on the Helm install and prepare the corresponding prerequisites. For example, for tiered storage, you need a bucket and a service account for it. For TLS, you need to pre-deploy a certificate manager and wire things up correctly. If you're wondering, CG has an excellent tutorial on the subject at the following link appearing on the right. We also covered a lot in this section, so better to leave with some checklists for your Pulsar in GKE experience. Remember that we can create the GKE cluster with the GKE bootstrap script from StreamNative Charts. Next, prepare it with the Helm prepare release script. From there, we just deploy using Helm and set any special value with the -- set. In GKE, the proxy, Pulsar Manager, and Grafana are already exposed and we can access them through the browser. Setting the proxy URL into the Pulsar client configuration, we can use the Pulsar client CLI or any script as usual. If you want to add any extra components, there is plenty of material in the StreamNative YouTube channel. Also, the community is really open over Slack. To catch up, we revisited how to deploy Apache Pulsar to Kubernetes with Pulsar Helm Charts, both locally to Minikube and in production to Google Kubernetes Engine. It is not complex at all to extend this production deployment to AWS or Azure, so I encourage you to try it out. I hope you enjoyed this video, learned how flexible are the Pulsar Helm Charts to deploy almost anywhere, and continue rocking with Apache Pulsar.